After we have amplified our DNA by the polymerase chain reaction, we will then analyze our DNA by gel electrophoresis. Agarose gel electrophoresis is a method that is used to separate DNA on the basis of its molecular weight in base pairs. How this is done is by running our amplified DNA through agarose gel under the influence of an electric current. This electric current will then correspond to the size of the DNA in base pairs and cause it to separate and run through the gel at different rates based on its size. In order for us to do this, we must first make up our agarose gel. In order to make up a 1% agarose gel, we will be using 0.1 grams of agarose powder and 100 milliliters of our TAE buffer. Our 0.1 grams of agarose powder has already been measured out and aliquoted using our balance. We will then add this 0.1 grams of agarose powder to our TAE buffer and heat it up in order to bring it to a boil. This will allow our agarose powder to completely dissolve into our TAE buffer and form a molten agar, which would then be poured into our gel mold. After we add our agarose powder to our 100 ml of TAE buffer, we will then place it onto our hot plate and allow it to come to a boil. As previously stated, this would allow the agarose powder to completely dissolve into the TAE buffer and make a molten agarose that can then be used as a gel mold to be able to run our gel electrophoresis. So after we have made up our molten gel, this is what it looks like, a 1% agarose gel. We will then pour our molten gel into our gel mold. So it's still a little bit hot, so I'm going to use a makeshift oven mitten, but we can also use oven mittens. When pouring our gel mold, we have to make sure that we minimize the presence of bubbles and that we maximize the spread of the gel throughout the mold. We will then leave this molten gel to set for about a half an hour. We will then pour the remainder of our TAE buffer to fill up this gel mold, and then we will load our amplified DNA onto our gel to be able to run the current through it to be able to continue our gel electrophoresis. After we have set our gel in our gel cast and we have removed our amplified DNA in our PCR tube from our thermal cycler, we can then subject our amplified DNA to gel electrophoresis. We remember that gel electrophoresis entails the separation of DNA on the basis of its size in base pairs. In order to do this, we have set up an agarose gel comprised of agarose powder and TAE buffer. We have then filled our gel tank with TAE buffer. We have also added ethidium bromide to our gel. This is important because ethidium bromide is a stain that is specific to DNA. It is also known as an intercalating dye, and what it does is that it gets between the double helical structure of DNA and will allow it to be visualized under ultraviolet light. We will then take our gel mold comb and remove it from our structure. This reveals the invaginations that are present within the gel. These invaginations are what will be used to be able to take up our DNA, our amplified DNA of choice, and to place it into our gel. We will take just about 6 microliters of amplified DNA and place it into our gel. It is important to note that we must also place our DNA ladder into our gel. This DNA ladder is a pre-ordered size scale in base pairs of DNA. This will be able to act as a comparison and tell us the size of our DNA of interest in base pairs. I am now going to attach our gel tank to our electrophoresis power pack. I do this by attaching the cathode to the cathode terminal and the anode to the anode terminal. I will then plug in my power pack and I will turn it on and adjust its voltage to begin my electrophoresis process. The electrophoresis process has begun and will be confirmed by the presence of bubbles in the gel tank. I have then taken my gel that contains my amplified DNA and placed it into the viewing area of an apparatus known as a transilluminator. The purpose of this transilluminator is to shine ultraviolet light onto the DNA that would then allow the DNA to be visualized. Remember that we have added ethidium bromide, our intercalating dye, to our DNA in our gel, which would then allow the DNA to fluoresce under ultraviolet light. I place the viewing apparatus on top of my transilluminator. Ideally, I would dim the lights and I switch it on. I can then visualize my amplified DNA in bands under the influence of UV light.